think we are going to see explosion of this market, and you will not have a lot of factories that are not connected to the internet and leveraging the latest and greatest of machine health, digital twin, automation, software, etc. And it's a greenfield. 90+% of this industry today are pure analog.
Welcome to the 5-Year Frontier podcast, a preview of the future through the eyes of the innovators shaping our world. Through short, insight-packed discussions, I seek to bring you a glimpse of what a key industry could look like 5 years out. I'm your host, Daniel Darling, a venture capitalist at Focal, where I spend my days with founders at the very start of their journey to transform an industry. The best have a distinct vision of what's to come, a guiding North Star they're building towards, and that's what I'm here to share with you. Today's episode is about the future of manufacturing and robotics. In it, we cover advanced factory automation, how digital twins simulate and optimize manufacturing lines, AI-led product and part design, nanotechnology, and the next generation of physical technology founders and startups. Our guide will be Lior Susan, a pioneering force in digital transformation for physical industries who wears the hat of both a CEO and an investor simultaneously to extreme success. A serial entrepreneur, Lior is CEO of Bright Machines, delivering advanced robotics and automation for manufacturing. Funded to the tune of $300 million, Bright Machines operates out of the US, Mexico, and Israel. Its key funder is the VC firm Eclipse that Lior also co-founded and works as a general partner, a firm that has been one of the first specialists in physical industry transformation and has since grown to manage over $3 billion and partner with over 90 companies. Lior sits on both sides of the table and offers a uniquely deep perspective on how the world is being reshaped today. Lior, wonderful to have you on to talk today.
Great to see you, Daniel. Thanks for having me.
We're here to talk about this coming physical industry renaissance, or I've heard you eloquently say the industrial evolution, which is basically this rapid technical innovation coming for our physical industries, ranging from manufacturing to aerospace. So why are we talking about this now? Has there been a big change in acceleration and pace of innovation? And what can you point to as kind of like the main contributors?
The innovation that occurred in the digital world did not really migrate to the physical world up till recently. There is a multiple of reasons why it's now happening, both from technology matureness and the infrastructure that is being built essentially in the last 20 years, but also from a macro point of view, everything from geopolitics issues, global warming, labor shortage, onshore manufacturing, and areas that are just pushing those industries to have a digital transformation. And as a result of that, we believe we are in the very front phase of industrial evolution.
So a real convergence there. Maybe we can focus a little bit on the technology tailwinds. What are some that you can pull out?
It's interesting because, probably the most trendy things we'll be talking about it will be an AI right now. Although I actually will talk about things that are happening in the last 20 years when the reality cloud infrastructure, mobile, semiconductor proliferation, power consumption of those semiconductors, manufacturing that opened their gate for high mix, high volumes. All of those, both supply chains, logistics, as well technology progress from open source to DevOps and things that we always thinking about it from the web and the internet, actually made it very profitable and attractive to physical industries, because you actually can start a company in a physical industries and about 1/10 of the capital that it's required not too long ago, maybe actually 10 years ago. And the speed that you can move, because the ecosystem is being aligned, is about 10x. So you take 1/10 of capital with a 10x speed and you actually get the transformation.
Amazing, amazing. So a lot of new entrepreneurial entrants in that space. And is everyone still trying to impact the same important metrics in the industry around manufacturing, speed, reliability, cost, or is the scope of those kind of metrics expanded with the innovation?
It depends on the industry. It would be a slightly different answer. But, if you're looking, let's take the automotive industry, it's still people, when Tesla was breaking the barriers and building a technology company that also building a car rather than a car company that's using tech. And that's distinction is actually what we are looking for. We are looking for a tech native businesses that also building manufacturing or building a car for that case. they still needed to build a great car that will have a cost, range, service like any other car or better. But what they were able to do naturally with the electrification and providing the car essentially as a big computer, leveraging a lot of semiconductor parts and a lot of software that they built, they were able to introduce a new experience that it was very rare in the world of automotive. And I think, the rest is history. Still, if you're manufacturing products, the people will want to see unit per hour, the cost of the product, the yield of the product, the throughput of the manufacturing. But I think you have an opportunity now, for example, to do it with robotics, leveraging foundational models or ML stack that will allow you to actually dealing with high mix, something that is very hard to do with traditional manufacturing. So I would say you need to know how to live in those industries and what is the key metrics that those industries are looking for. But now you can also imagine how you can technology and push those industries to an areas that they never seen before.
Fantastic. And you definitely live in those industries in your role as CEO of Bright Machines. And one of the statements you make is that you're building this hardware backbone of AI. Just wondering what you mean by that, and if you could explain what some of the things you're building there.
Yeah, absolutely. We're doing at Bright Machines. We're leveraging artificial intelligence foundational models and robotics in order to train and teach robots how to build electronics like humans and better. And we're also building the software that will allow you to design electronics for robotics and automation rather than designing electronics for humans to build. So we are leveraging also foundational models to teach engineers how to build those products for design for automation rather than traditional design for manufacturing. But what we find is there is an amazing renaissance in the electronics manufacturing space because of AI workload. And the renaissance is people need to introduce new servers and new GPUs and new storage systems in the pace of software. Although electronics manufacturing is being built for low mix, high volume. That's exactly what we did in the last 50 years. We went to China, we went to low cost areas and built these very large factories. And I don't know if you know the stat, but 97% of the world's electronics is being built by hand.
Wow.
The iPhone in your pocket is mainly built by hand. This PC that you're talking about is being built by hand. So we actually building the most advanced electronics like craftsmen's. Like you build the wood table that my computer is sitting on. And I envision that we are going to leveraging robotics and software in order to transform how we build those products. And then the AI market showed up and say, we are not good with low mix, high volume anymore. We need high mix. We want to change the design of the product constantly. And we just met an amazing product market fit with our stack and what this market are pushing.
So the real quest is how you get that 90% and automate a lot of that and increasingly introduce robotics into that mix. Do you have a time frame in mind of when we will start to tip over into a more automated manufacturing future?
We're already doing that. I would say that I walked on flextronics manufacturing in a city in China called Zhuhai in 2013 and saw a couple of tens of thousands of people standing next to each other and building the most advanced electronics by hand. And I told my friend that was the plant manager there, in my lifetime, I will have robots building those products. I started Bright Machine in 2018. We are in the beginning, showing that we actually can use automation in order to do electronics manufacturing at scale. We have a long road in front of us, but I'm super excited by the speed that the company is moving.
And one of the advances that you do is around these microfactories. Can you unpack a little bit about what they are and sort of who they serve?
Yeah, so basically microfactories, thinking about it, this long line of people that's standing next to each other building the product. We have a long line of robots standing next to each other, and we teach them with software how to do the same human behavior that you will do in manufacturing line. Pick and place, putting a screws, putting a CPU, putting a GPU, putting a fan, do inspection, do maybe some soldering or gluing. We teach the robots how to do the same things that you will do with humans, and then we deploy it at scale. Those microfactories are a hybrid solution between humans and robots. And whatever human is really good at, we will do with humans, like, for example, cabling. Robots are not good with flexible materials yet. Humans are really good with that. So humans will do it in the manual station, and whatever robots are good, we'll do it in the robots. But what we are offering the customer is an end-to-end view from the data and the applications that we are running, regardless if it's the humans or the robots that are doing the task. And introducing what I call digital manufacturing flow. So you take a factory floor that today is an analog and you make it a digital. So you have data, so you can train models and make it better and better and better.
And that starts to evoke the notion of this digital twin, right? Like, an area that holds a lot of promise for the industry, which is basically a virtual representation of a physical asset. Is that what you're starting to see roll out across the factory? We can start to simulate these environments and really start to optimize the process in software and then apply it in the physical world?
Yeah, we're actually partnering with NVIDIA, with Omniverse, with their digital tools, solutions and simulation. What I think the real power happening when you actually take a digital tool and you connect it to the physical world in order to see if your assumption on the digital tool was correct in reality.
Yeah.
And the next steps after that, you take the data from that line and you train an ML model that can help me design the next generation product better, because I actually learn from the mistakes that I had on the designs and the qualities issues. And that's what we are going to introduce end of this year. I like to say we have the machines that building the machines, right? We are building GPUs that will be able to run AI with, when we are training our models of the GPUs that we are using for our robotic system. And I'm just blowing away by how advanced those foundational models and the MLs in general is actually crossing the chasm on simulations, physics, and also another company I'm on the board is called Augury, that putting sensors on those machines, industrial machines, collecting all of the data, and they have an ML engine that run and tell you when you're going to have an issue in the machine based on the machine pattern. In general, I think we are going to see explosion of this market, and you will not have a lot of factories that are not connected to the internet and leveraging the latest and greatest of machine health, digital twin, automation, software, etc. And it's a greenfield. 90+% of this industry today are pure analog.
Yeah, I can imagine that there's huge room for penetration in there. But like you said, there's all these macro tailwinds pushing it forward. And then you have the pure play technology native companies pioneering the way. So, we talked a little bit about software, but let's return to robotics a bit. There's a lot of money going towards these kind of multi-purpose robots, from Tesla to Figure. How do you think about the opposing futures of a all-capable single robot and then your masterfully specialized robots at Bright Machines?
I think it goes back to the application. And at the end of the day, the customers do not care. Do you using humanoid, or you're using robot, or you're using something else, AGV? They care about what is the UPH, the unit per hours, what is the throughput, what is the quality or the yield, what is the OEE, the efficiency of that manufacturing, and that's the thing they care about. Long term, I'm bullish on humanoids. I think humanoids will do a really good job for pick and place. I think there is a decade plus to get it into the cost that will allow you to actually use it at scale. Because remember that you're competing around against $30,000 per year human. That's the budget.
Yeah.
So it's even in, forget about low cost area, even in a higher cost area, you're talking about 30, 40,000 a year. You would not be able to use humanoids that cost $1 million a pop. There is a correlation between the value of the product that you're building and how much technology the customer actually able to push. If you build a $200,000 H100, they have X amount of money to give you, versus if you build these AirPods and it's a $50. We always on the chase of the highest value product in a high volume, because this is where I think most of the disruption is happening and going to happen in the next 5 years.
How about some of the bigger, more costly inputs like energy coming into that? What are the innovations you're seeing to make it more sustainable or more efficient in the manufacturing process?
Yeah, I mean, it's a space that we are spending a lot of our time, and we built multiple of company in lithium-ion energy storage like Peak, and we took a company public called Innovix and silicon anode space. I think there's a lot of innovation to be done. I think we will need to solve, as this industrial evolution is picking up, we will need to solve the energy evolution to support that. And it must be clean energy. And then you're talking about, okay, solar is like reached a point that is actually very profitable to leveraging solar and long duration energy storage in order to store it. But then, okay, not every place have a lot of sun and you need a lot of space. I think thermo, it's interesting. I think hydro, it's interesting. I think nuclear fusion in some point, not yet, but in some point will be interesting. So we are on the hunt to find a new green energy sources in order to power this industrial evolution.
And speaking of on the hunt, where do you sort of envisage, or where are you focusing a lot of your attention at Eclipse in terms of the underserved areas of innovation? Where would you like to see founders spending more of their attention deploying innovation into?
Energy is definitely one market of that I want to see more people working on this problem. I mean, I think, Daniel, one of the reasons that I think I have the best job in the world is I truly believe that the best founders in the world right now, looking on their heroes, and it's Jensen Huang and Elon Musk, that's solving physical industries problem. And that's what they've been doing, some of them 33 years like Jensen and some of them less like Elon. And they want to be like those guys. And they usually also been trained in companies like SpaceX and Teslas and Nvidias and Amazon. So they are coming with a lot of, even if they're first-time entrepreneurs, they're not the first-time operators. They're savvy operators. They know how to attract amazing teams. And I'm super bullish to work with those teams in order to solve tough problems that can be huge, that can drive this economy. But then to go back to your question, I would love to see more stuff in energy. I would love to see more stuff in innovation, in aviation, in mining, in manufacturing, in agriculture, in food. There is a lot of areas that we did not even scratch the surface of how we can actually innovate. Some of those industries will be harder than others, but all of them will change by technology in my lifetime.
Agriculture is a fascinating one, and you've had some experience building in that space as an operator. What are you seeing in terms of the frontier innovation in that space and how it could evolve?
Really tough industry, extremely low gross margin. Goes back to what we just talked about. It's moved away from produce and consume in the same place to, in the last 20 years, we industrial food production in a central way and actually make it really cheap, good and bad, by the way. But, suffering from the same macro issues that I talked before, lack of labor, there's no people to do those jobs, global warming, screwing everything around the climate, lack of clean soil. We poisoned a lot of the soils that we actually, and a lot of the ground that we live in the last 50, 60 years. It's for another conversation. We built a company to clean PFAS called Remedy. So, thinking about how to solve those problems, we are running out of sweet water. So we need more diesel. Super interested in the diesel market. I want to see more companies. But yeah, food production is one of the things that I'm personally passionate on, that yet to see something that could cross the chasm. Not indoor farming, greenhouses, some interesting, automation, some interesting, but yet to see something that I believe can be that company to change it, but on the hunt.
So you're not that bullish on the vertical farming innovations that you're seeing?
I think the problem with vertical farming is the cost of energy. Basically, in order to mimic the sun, leveraging LED lighting, the energy consumption is incredible. And you are fighting of a head of lettuce that costs $1. And you need to load all of that spend of robotic system, GPUs, and energy on $1. It just turned out to be really hard.
Certainly makes for a hard industry to innovate in. I want to take us back, if that's cool, to Eclipse and your exposure as a VC. Eclipse has done over 90 companies, has over 3 billion under management. You have been doing this for almost a decade now and are across some amazing businesses, not to play favorites, but can you just point out a couple that maybe are at the intersection of advanced manufacturing, product design, material science, all of these things that we're talking about today, and just unpack them a little bit further and maybe one in more detail?
Yeah, so I'm actually looking behind me, and there's pictures. We have pictures in each room, but behind me, here on the top, it's Augury, the company I mentioned. They're doing the industrial IoT for machine health and predictive maintenance. Here, it's Vulcan forms that they're using high-speed lasers to manufacturing metal parts, fully automated, high-end metal parts, mainly for the orthopedic market, but also for aerospace and defense and automotive. And basically, they're building a semiconductor-like manufacturing, but for metal parts. Here, it's a company called Cerebras that building wafer scale integration chips for AI purpose infrastructure. So they're building those huge supercomputers, leveraging their AI. Let me see what else we have here.
You've got quite a few photos out there.
I know. We have the Arc boat that building electrification of the maritime, and this is actually the Bright Machines robotic cells that you asked about. Daniel, I'm like blowing away by the quality of founders that we are seeing right now and how bold is those visions of these people to go and solve and build tech-centric companies and physical industries. And I couldn't be more excited about my multiple day jobs.
Maybe let's zoom in on Volcom as an example, both in terms of the company, the technology, and then maybe that founder DNA that you're alluding to.
Yeah, I mean, we started working with the founding team at Volcan in 2017. We led multiple of rounds on this company. The founding team came from PhD in digital manufacturing from an MIT. Before that, works for Mercedes-Benz for many years in their digital manufacturing team. And he also joined his professor from MIT to start this company. I mean, they show us a presentation of 3 slides. And they say, hey, we're going to use 160, if I remember right, 160 fiber lasers on a single bed in order to manufacturing a high-end metal parts, leveraging a fully automated process rather than a human-based with CNC. And, it sounds crazy, but we love the team and believe that they're going to be able to do it. And we led, 4 or 5 multiple of rounds in like back-to-back in this company. And the company right now sitting on a couple of billions of dollars in backlog, manufacturing metal parts for some of the most important companies in the world.
So we're talking about a cutting process where essentially they have lasers that are able to do really high precision cutting on metalwork?
They're actually forming the parts. They take a powder and they actually wave the lasers on this giant, each of those things, it's a one machine, inside those giant machines to build the parts, and then they have another process to cut the parts from the bed. But if you're familiar with traditional printers or 3D printers or metal printers that, we'll be able to build something very, very small. The size of that machine is in the size of my office, and they can manufacture many, many, many parts on each of those beds, leveraging the technology that they build. And that's what replace humans on a CNC machine, manufacturing those parts one by one.
Wow. So we're talking almost about 3D printing and forming metal components from there.
Correct.
That's really incredible. I had Phil from Carbon on to talk about 3D printing as well. And one of the things that stood out was this notion of AI-led design and how it unlocks this massive degree of personalization and sort of N of one designs at scale. Do you start to seeing more of that start to come on the market? And maybe that works in 3D printing, but how does it start to interplay this AI-led design of products into the rest of the manufacturing process?
This is exactly what we're building in Bright Machines and what we're going to call Designer that we will launch end of this year. It's the first attempt of that notion, but for electronics assembly. Rather than 3D printing that naturally would be only the mechanical. I'm here now talking about the thermal analysis. I'm talking about the mechanical. I'm talking about the electrical. And I'm going to talk about 500 parts that needs to make one server. Can I actually leveraging AI design tools to help me better design those servers based on the insights I'm getting from the robots in the fleet? That's actually exactly what we will announce. But we have another company called Augmenta that leverage a foundational model software for the construction market and able to do it on a CAD, and automated electrical engineers and plumbers drawing for the construction market. The results is unbelievable. They're able to do drawing, the AI model able to manufacturing a drawing with multiple of options in about 300 times faster than what an army of designers of CAD can do. I think the world is going there. I think we're going to see more of it.
So do you think that the first sort of penetration and massive component that will be automated could be this design process and could be this sort of feedback loop of data from what's happening in the physical world into the design process?
Exactly. The reality is we will be able to accelerate the robotics adoption if it's been designed for robotics. Because if a designer designing the product and he's putting 4 different screws on the product, why you put 4 different screws? I don't know. I just like those 4 screws. I'm like, okay, when you like 4 screws, I need 4 ball feeders to the robots to put each of those screws. Can we actually put one type of a screw? Or can you put the board like that? It will be easier for the path planning for the robots to reach rather than put it like that. All of that is exactly what we train the AI engine for that designer to be able to tell you during the design of the product. But I will tell you in the industries that I'm operating, that I talked about a few of them on the wall here, is the speed of change and the time to market of the people that will be able to introduce a new change. The amount of money behind that is huge. And they're willing now to challenge the way that they traditionally design those products and manufacturing the products in order to gain speed, in order to gain standardization, in order to gain geography agnostics. They want to be able to move their manufacturing across the world without thinking twice. Today, it's impossible. So there is like a multiple of huge macro changes, from labor shortage to geopolitics to opportunities in the market, that's pushing now those industries to that place.
How do you view the supply chain of the future, the global supply chain of the future in 5 years' time?
Usually people are saying manufacturing, but the reality, they're talking about 3 different industries. You have manufacturing, you have supply chain, and you have logistics. Manufacturing is I build a product. Supply chain is the parts that I'm using to build that product, and logistics, I move this product from point A to point B. Those 3 industries connect to each other like that. And now you'll start seeing the manufacturing moving onshore, especially on the high value product. So you start seeing more suppliers building up close to the manufacturing. Now suppliers will take longer time to move because naturally on this product I have, a couple of hundreds of parts. So it takes time, not like manufacturing, it's a one thing. Suppliers will take time. And now logistics, it's a new thing because I don't need to put that product on a boat for 2 months from China to US. If I sell in US, can I build it in US in a competitive price? If yes, you just change the logistics landscape because you can build to order rather than build to inventory.
Big changes.
Big changes ahead. In our lifetime, Daniel. In our lifetime.
And are you guys doing anything in the space industry or looking at how some manufacturing can be taken into outer space?
Yeah, we looked on a bunch of these zero gravity companies. We didn't make any investment yet. We did invest in a company in the space defense market, company building a prime for space called True Anomaly. And we did invest in a company called Ursa Major that manufacturing rocket engine for solid motors, hypersonics, and space. So we kind of playing yet in the picks and shovels for space. We didn't make a proper space investments yet, but I think it will come.
And just circling back to some of these founders that you mentioned, Musk and Jensen, there's so much innovation that they brought on to the world. Is it something that proliferates out to other entrepreneurs as well, like in software where you have open source and you're able to benefit and build on top of other people's innovations? Are we seeing that kind of same ability to collaborate and to learn and to leverage each other's innovations in the physical world?
At least from what I see in the physical world, it's mainly the human capital. It's actually the quality of those people that build it for Musk or Jensen and now leaving to build for their own. And they know they have the secret sauce of how to connect the robots to the computer vision, to the control, to the cloud, how to use machine learning in order to do something special in pharma manufacturing, leveraging automation and software. So I think it's mainly there. Of course, there is a tons of tools that is being built that now is getting better and better. We invested in one of those companies called Foxglove, that building tools for robotics companies to allow them to, both in open source as well, non-open source, the ability to run better simulation and run better the telematics of those robots and run better the fleet. So I think we are about to see a big waves of companies building tools for physical companies. Naturally, the whole omniverse of Jensen is exactly that. So we're using it constantly, and I think we're going to see more building similar platforms.
Lior, we're going to have to wrap it up and end it there. I've really enjoyed the chat today. Such innovations and impact you're bringing to the market, both from the Bright Machine angle and building that company, as well from the Eclipse and the investment side, and backing some of the really transformative companies coming to reshape the physical world. So excited to watch and follow the journey as things unfold, and such an incredible moment in time to be innovating in this field. So thanks for coming on.
Pleasure being here, Daniel. Thanks for having me.
How awesome to hear from Lior today. Not often can you benefit from the knowledge of someone who both operates and invests simultaneously and so successfully. As you probably concluded, the transformation headed for physical industries is incredibly complex and multifaceted, yet far too monumental to ignore. The next generation of founders are innovating on all frontiers to bring about change, from digital simulations, AI-led part design, robotic manufacturing lines to material sciences and more, the impact of which will reshape industries, economies, and geopolitics in the decades ahead. The best way to follow the work of Lior is to head over to Eclipse Ventures blog, found at eclipse.vc/blog. I hope you enjoyed today's episode, and please subscribe to the podcast to listen to more coming down the pipe. Until next time, thanks for listening and have a great rest of your day.